Greetings and welcome. Subscribe the channel Thermal Engineering for video sessions. In this session, you will be able to explain types of fluid based on Newton's law of viscosity and stress strain diagram based on rheology. Let us discuss about rheology. Rheology is Greek word. Rheo means flow or stream or current. So science of deformation and flow of fluid is called as rheology. Fluids, generally complex mixtures, are studied under this science, that is rheology. Fluids are classified in different way. Generally, fluids are of two types, liquids and gases. In other way, fluids are divided as ideal fluids and real fluids. So ideal fluids, the fluids which are having zero viscosity, no surface tension and incompressible. In true sense, no such fluid exists in nature, means every fluid has some viscosity. However, fluids which have low viscosities such as water and air are treated as ideal fluids in fluid mechanics applications. Real fluids. Real fluid is one which has viscosity and compressibility, and they are available in nature. Based on Newton's law of viscosity, means tau is equal to mu into du upon dy, where tau is shear stress, mu is viscosity and du upon dy is deformation or shear strain. By this, fluids are classified as Newtonian fluid and non-Newtonian fluid. Now Newtonian fluid means fluid which follows Newton's law of viscosity. Means in this case, viscosity does not change with rate of deformation. Here, linear relation between magnitude of shear stress and rate of deformation is found. So the formula for this kind of fluid is tau is equal to mu into du upon dy. Now these fluids are shown by using the diagram that is called as stress strain diagram. This diagram is obtained from the science rheology. That is why it is also called as rheological diagram. Now in this diagram, on a vertical axis, shear stress is shown, and on horizontal axis, shear strain means du upon dy, that is rate of deformation, is shown. Now as the horizontal axis, it has zero shear stress for the deformation. Such fluids are ideal fluid. So ideal fluid is represented by horizontal line. Here the vertical axis means in this case there is no permanent deformation at zero shear stress. So in this case, this is called as elastic solid, that is represented by the vertical line. Now here this is Newtonian fluid, means which obeys the Newton's law of viscosity. These fluids are water and oil. Non-Newtonian fluid means fluid which do not follow Newton's law of viscosity. In this case, viscosity changes with rate of deformation. Such fluids are relatively uncommon, and here mathematically these are indicated by the formula tau is equal to mu into du upon dy raised to n. Now based on this value of n, there are again further two types. Now here blood is a non-Newtonian fluid. Also molten metal, this is also non-Newtonian fluid. In shear stress strain diagram, we can show this non-Newtonian fluid that is called as pseudoplastic fluid. Now in this case, the value of n is less than 1. Now these fluids are already, we have seen, non-Newtonian fluid because value of n is less than 1. Here the viscosity decreases with increasing shear stress, means by the application of shear stress your resistance to the flow decreases. For example, tomato ketchup, by the application of shear stress, here we find the tomato ketchup is becoming thin. That's why it is called as shear thinning fluid. Also another example, paper pulp and paint. Here we see by the application of shear stress, the layer of paint that becomes thin and it flows, means shear thinning fluid. Now here other fluids which show the opposite effect and are called as shear thickening fluid or dilatant fluid. So here value of n is greater than 1. So formula we see here for this. The example is atta. In this case viscosity increases with increasing shear stress, means more the fluid is sheared, the more viscous it becomes. That is why it is called as shear thickening fluid. The best example of shear thickening fluid is quicksand, a thick mixture of sand and water. So as we all know from Hollywood movies, it is easy to move slowly through quicksand since the viscosity is low. But if you are panic and try to more quickly move, the viscous resistance increases considerably and you get stuck. Some examples of this category, that is butter and slurry. Next category is plastic Bingham fluid, that is non-Newtonian fluid. These fluids are represented by straight line which is intersecting the vertical axis at the yield stress. Here we see this is yield stress. This fluid is called as Bingham fluid. Now in this case here we see at this point no deformation, but when the initial yield stress is exceeded by the application of shear stress, then their deformation is starting. So after that fluid is behaving like Newtonian fluid, means it is following the law of Newton's law of viscosity. That's why the line is straight line. Now the example of Bingham fluid is toothpaste. Here we see when the toothpaste is applied on the brush, here we don't find deformation, but when the application of shear stress exceeding the value, that is yield stress, then it starts flowing. So while we are doing brush. Likewise sewage and sludge are the examples of the Bingham fluid. Next category is thixotropic fluid. It is also non-Newtonian fluid. So it is shown by this curve. So here we find, as this is a curve, means non-linear relation between the magnitude of shear stress and resulting rate of deformation beyond an initial yield stress. The example of thixotropic fluids are gel, lipstick and printer's ink. So here we see the complete stress strain diagram, which is showing all the types of fluid that we discuss: Newtonian, non-Newtonian fluid, in that these two means pseudoplastic and dilatant. Here this is Bingham fluid and thixotropic fluid. So at the end of this session, you can explain types of fluid on the basis of Newton's law of viscosity with practical examples, and you can explain stress strain diagram. Subscribe the channel for further video sessions. Thank you.